The next thing that we're going to learn about is the law of cosines. Looks a lot more confusing than the law of sines, but it's really not that bad. So first of all, let's talk about when we're going to use the law of cosines. In order to use the law of sines, we have three ratios set equal to each other, and then we cross multiply. Well, you can only use that if you have a full ratio. So, for example, if I have the sine of A over 5 equals the sine of B over 7 equals the sine of C over 9, I can't use the law of sines because I don't have anything on top that I can cross multiply. So in the case like this, you're not going to be able to use law of sines, so that's where law of cosines comes in handy. So in order to use law of sines, you have to be able to complete one whole ratio so that you can use that one to cross multiply with. If that doesn't happen, then you're going to have to go to law of cosines. Okay, so law of cosines. This is the one that I remember. And you'll notice that the front looks very similar, looks exactly like the Pythagorean theorem. C squared equals A squared plus B squared, and then minus 2AB cosine C. In textbooks, you'll actually see two more law of cosines written with A squared and B squared on the other side of the equal sign. But to me, that's way too much to memorize, and a lot of times it's not A's, B's, and C's anyway. It's P's, Q's, and R's, or S's, T's, and V's. So the biggest thing you just have to understand is whatever angle you're either trying to find or that you know is the same variable as the side that's on the other side of the equal sign. And from there, it's just, like I said, Pythagorean theorem minus 2 times these two same sides. All right, so let's do an example. And we're going to solve the triangle, mean find all of the missing pieces, the same way that we did with law of sines. So I'm going to start here by finding angle A. Why not? Plus, that'll give me a chance to show you how we readjust this formula without looking at those two guys, because we don't want to have to memorize too much. All right, so if we're trying to find angle A, then here in the back, that's going to be the cosine of A, which means that on the other side of the equal sign is the side that goes across from there. So that's 5 squared. Then we put the other two sides over here. So 8 squared plus 12 squared minus 2 times 8 times 12. Again, the angle that you either have or are trying to find matches up with what's on the other side of the equal sign. And then you just fill in from there. Okay. So now we're going to do some arithmetic. We have 25 equals 64 plus 144 minus 192 cosine A. Combine our like terms here. 25 equals 208 minus 192 cosine A. Now, here's the most common mistake on this. This is a coefficient of this unknown amount, so we cannot subtract these. So we pretend in your head this is a big old X. So we're going to subtract the 208 and then divide by the negative 192. So when we subtract 208, subtract 208, so we get negative 192 cosine A equals 25 minus 208, which is negative 183. Divide by your negative 192, and you get that the cosine of A equals 0.953125. But I'm going to keep that whole decimal in my calculator just like I did last time. Now, just a quick reminder, make sure that your calculator is in degrees, not in radians. If it's in radians, you're going to get the wrong answer because we're working in degrees. Okay, so let's go back here. So now we have the cosine of A, but we need to know what A is. So we have to do inverse cosine, so second cosine, second answer to bring my whole decimal down, and A is approximately 18 degrees. Now, so I've used the law of cosines, I found one angle. You could use the law of cosines again to find another one, or now that we have an angle, we could plug into the law of sines. So we have the sine of 18 over 5 equals the sine of b over 8 equals the sine of c over 12. Because now I have one whole ratio filled out, so I can use my law of sines. So again, in order to do that, let's clear that out. I would have 8 times the sine of 18, close my parenthesis, divided by 5, so that's 0.494, but then I have that equals the sine of b. So the sine of b equals 0.4944, but I have to get rid of sine, so inverse sine. So b equals approximately 30 degrees. Uh-oh, wait a minute, got a typo. No, I don't. I lied. Okay, 30 degrees. Now, I could use law of cosines again. I could use law of sines again, but I know 2 of the 3 angles of a triangle. So I'm not gonna do either one of those. I'm just gonna add 30 and 18 together and subtract from 180. Because that makes my life much easier. So C equals 132 degrees. And if you put that up there to double check yourself, the largest angle should be across from the largest side, middle angle across from the middle side, smallest angle across from the smallest side. Okay, this is the harder type problem with law of cosines. The next one I'm going to show you is really easy, but you still have to know the formula. All right, so let's set this up here. So we have, if we were going to try to use the law of sines, we would have the sine of 45 over little a equals the sine of b over 6.2 equals the sine of c over 7.8. So again, here's a case we can't use the law of sines because we don't have one full ratio set up. So there's no way we can cross multiply when we have 2 unknowns. So we're going to have to use the law of cosines. So let's use the law of cosines with this angle in order to find the third side. That'll fill out that ratio, and then we could use law of sines from there. So here we go. So the cosine of 45 is what goes back here. So remember, the angle that's involved, the side opposite it, is the one that goes on the other side of the equal sign. Then you just kind of fill in from there. So we have 6.2 squared plus 7.8 squared minus 2 times 6.2 times 7.8. Ooh, that's really ugly. Let me put that in parentheses so it doesn't look like so many decimals. Well, now what do you notice about this? What I notice about this is that I have a bunch of numbers over here. There's no variables on the right side of the equation. So I can just plug that whole thing straight into my calculator the way it is. So let's do that. So I would have 6.2 squared plus 7.8 squared minus 2 times 6.2 times 7.8 times the cosine of 45, 30.89. Let me just double check that I didn't type anything in wrong. That's good. So a squared equals 30.888, blah, 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 65, whatever, whatever. But that's a squared. We need to find a, so we take the square root. And again, bring that whole decimal down. Don't round until the end. A is approximately 6. So a is 6. I can then plug that in there. And then I just need to find b and c. Again, you could go back and do law of cosines again. Not going to hurt anything. But most people tend to like law of sines better. So I'm just going to go ahead and cross multiply here to find angle b. So that would be 6.2 times the sine of 45. And then close that parenthesis. Divide that by 6. And I get that the sine of b is 0.730. Inverse sine. and I get that angle B is approximately 47 degrees. And again, once I know A and B, there's no sense to do all that work. Just subtract from 180 to get C. So 45 plus 47, subtracted from 180, 88 degrees. And again, double check yourself. Largest angle across from largest side, middle angle across from middle side, smallest angle across from smallest side. Okay, that's about all there is to it. Today we're gonna go easy on you, no word problems.